Sorry I'm out today. This video should be pretty quick and easy. I feel like this next concept is pretty quick and easy for you guys. But don't worry if you feel like it's struggling or it doesn't all come together. We will go over this tomorrow. Okay. Last week we spent everything that we did with trig was based on right triangles. So you had to have a right triangle in order for any of those things to work. Those six mean ratios, all that stuff, Pythagorean theorem. It was all based off right triangles. Now I want to look at some instances where we can use trig, some versions of trig, not exactly what we did last week, but some versions of that, and that work on any triangles, right and non-right triangles alike. So the first thing we're going to do is what's called law of sines. Law of sines has a formula. It looks like this. It relates ratios. So it says the sine of angle A divided by side A is the same thing as the sine of angle B divided by side B, which is the same thing as the sine of angle C divided by side C. Now, that looks very funny because you are not used to equations with two equal signs. The reality is we are only going to choose two proportions that we need per problem. Okay, so with this, we only use two ratios per problem. And we'll get into how exactly we determine which ratios we use in a second. So know that it says here to use law of sines, you have to either know two angles in any side or two sides and the angles opposite of that. Another way to say this is that we need what I call a matching pair. That's not a very technical definition, but what I mean by that is I need to know at least one pair of an angle with its corresponding side, which would be the side across from that. Okay? So we can use law of sines to either find angles or sides. So the first two we're going to find sides, this next two we're going to find angles. Okay, so number one says we want to find side BC. Side BC is across from angle A, so that is the same thing. It's the same thing as side A. Now, here's what I meant about that matching pair stuff. I'm only going to use two of those ratios at a time. So I'm either going to use the ratios with the A's, the B's, or the C's. First thing I'm looking for is a matching pair. Is there a pair either with the A's, where I know angle and side, with the B's, that I know its angle and side, or with the C's? And if you look at that, we have on number one, I have a matching pair in the C's. I know angle C, and I know side C. So that is definitely one of the ratios I want to use. I definitely want to use the sine of C over side C because I know both of those things. Now, because I'm looking for side A, the other ratio I have to use is the one that includes side A. So that's how I determine which ratios I use. The first ratio, well, technically it doesn't matter which side it's on, but one of the ratios should be the matching pair that you have, and the other one should include what you're looking for. So after I determine what ratios I'm using, fill in your information. So I know that angle C is 22. So I'm talking about the sine is 22 degrees. Side little c is 24. Angle A is also 24, so the sine of 24 degrees over side little a. Now, at this point, you have to go back to your middle school strategies of solving proportions, and we cross multiply and we divide. So we're literally going to multiply in the direction that I have both answers and divide by the other one. So in our calculator, that looks like 24 times the sine of 24. Get an answer. Then I'm going to divide by sine of 22. And we're going to continue our strategy of rounding this to the nearest tenth. So this looks like 26.1. So side A is 26.1. And that's it. Okay? Similar in number 2. It says find AB. Well, AB is across from angle C, so that's side little c. Again, to determine the ratios that we need to look for our matching pair. I happen to have a matching pair with the B's. I know angle B and side B. So one of my ratios is going to be the sine of angle B over side B. My other ratio has to be what I'm looking for, which is little c, so I have to use the sine of angle C over side C. Okay, let's fill in what I know. Angle B is 36 degrees. I'm talking about the sine of 36. Side B is 25. Angle C is 15. And I don't know side little c. Okay, just like before, I'm going to cross multiply and divide. So I'm going to multiply with the two things I have answers for, divide by the other one. So I'm going to say 25 times the sine of 15 divided by the sine of 36. Again, stick to the nearest tenth, and I'm going to say this is 11.0. So side little c is 11.0. Okay. All right, now let's look how we use law of sines to find missing angles. Okay, the initial setup is the same. So I know in number 3 I'm looking for angle C. I am still searching for that matching pair because honestly, if I don't have a matching pair, I can't use law of sines. There will be a different strategy that we will look at on Wednesday or Thursday this week that will show us what we can do if I don't have a matching pair. But I really need to search that matching pair. So I do have a matching pair in the A. I know angle A and side A. So one of my ratios is going to be the sine of angle A over side A. Since I'm looking for angle C, that has to be included in my other ratio. So I need the sine of angle C over side C. If I fill in what I know, angle A is 89 degrees. Side little a is 33. I don't know angle C. And side little c is 8. Okay, my initial strategy at this point is the same with the cross multiplying and dividing. So I multiply and then divide. So initially I look like 18 times the sine of 89. Get an answer and divide by 33. Now, it doesn't seem very feasible that that angle is 0.54 degrees. And it's not, because what you need to remember is you're looking for an angle. And the one thing that does apply here, that did apply to us last week, whenever I'm looking for an angle, I use inverse. Now, I need to be a little bit careful when I use the inverse here, because I want to make my answer as accurate as possible. So when I do inverse sine, I'm going to hit second sine for the inverse. But I want to really use that whole answer. I don't want to approximate that, because if I approximate prior to getting to the end, then it just really throws my answer off. So, and that being said, I don't want to type all that out. So the way I can get my calculator to reuse that answer for me, if I look above the negative sign, there's the letters A and S. That means previous answer. So after I hit second sign, if I then go and hit second again and hit the negative sign for answer, that tells my calculator to use its previous answer. Okay, so this tells me that angle C is 33.1 degrees. So angle C is 33.1 degrees. Okay, similar with number 4. I am looking for angle B. Again, I need to find that matching pair that I have. I have a matching pair in the C's. I know angle C and side C. So I'm going to use the C's as one of my ratios. Since I'm looking for angle B, I'm going to have to use the B's as my other ratio. I'm sure some of you are wondering, do you have to write out that first line I've been writing out with just the variables? That's up to you. I'm doing it because this is a new concept and I want you to understand what we're doing. But if you feel like you can jump right into that second step where you're plugging in all the numbers, I'm good with that too. Okay, so if I fill in the numbers here, angle C is 129, so I have the sine of 129. Side little c is 33. Angle B I don't know yet, but I will momentarily. Side little b is 11. Okay, just like before, I'm going to cross multiply and divide. So I'm going to say 11 times the sine of 129 divided by 33. Whoops, hold on. I didn't hit divide. Oh, wow. Failing all over the place. I'm sure you already have the answer by now. That's good. Divided by 33. There we go. Again, I need, since I'm looking for an angle, I need to use inverse just like we did last week. So now I need to hit second sine, and I'm going to, of my previous answer, so I hit second answer. So angle B is 15.0 degrees. Okay? Now, if I look at the bottom two, the only deal with the bottom two is I don't have a triangle. So that means I've got to draw it. Well, we saw that last week. If I don't have a triangle, I need to draw myself a triangle, which is fine. That's not a big deal. So I'm just going to draw a generic triangle any way you want, kind of. Pretend these lines are straight. Label it A, B, and C. And let's fill in what I know. So angle A is wherever you put your angle A is 61. Wherever you put your angle B is 30. And side little c is 16, so that's across from angle C. Remember, lowercase letters symbolize sides, capital letters symbolize angles. Now, this says find side little b. Well, if you're looking at this, it doesn't look initially like you have a matching pair. However, you do know 2 out of 3 sides of a triangle, so those basic rules of triangle relationships apply. You know there's 180 degrees in a triangle, so if you add up the 2 that you have and subtract from 180, that would tell you that angle C is 89 degrees, which then you really would have a matching pair. Okay, let's set up 6, and I'm going to let you try these two. So again, draw a triangle any way you want, doesn't really matter. Label it A, B, and C. Angle B, wherever your angle B is 84. Terrible 8, that works. Side little a is 12. Side little b is 19. And you were looking for angle A, and you do have a matching pair here. So go ahead and pause the video, take a second to try these, and then come back. All right, guys, hopefully we agree. At this point, so after you've had a chance to check these and stuff, at this point, the sub should have also given you a worksheet that has front and back on it. You should have no problem finishing that in class. These should go pretty quickly for you. And don't worry, we're not going on to anything new tomorrow. We will still work on this tomorrow in class. Thanks, guys.